Hello, and in this video we're going to talk about the rest of chapter 4, which deals with discrete or binomial and Poisson distributions. All right, so let's define what those are first of all. So those are going to be probability distributions, just like the discrete probability distributions earlier, but they're going to have a certain type of distribution. So both of these are going to be countable, meaning that the numbers are going to be countable that we use in the x value of the chart. Each one will have a probability. So when we graph this, it would look like a bar graph on each of these cases, because each value would have its own probability. So a binomial distribution uses a binomial experiment here. I've written it down here. It has a fixed number of trials, which is called an n value. It either has success or failure as an outcome. So each trial is going to have a probability of success and a probability of failure. The probability of success and failure added together is always going to equal 1. In order for it to be a binomial experiment, each trial has to be independent of one another. That means it can't depend on one another. Like flipping a coin, it would be an independent trial. Flipping the coin first doesn't affect the second one. Okay. Now the outcomes that we generate will generate a distribution. Whoops. And that distribution is going to have a mean and a standard deviation. The mean and the standard deviation is just given by these formulas. They're very simple formulas. It's just going to be the n value, the number of trials, times the probability of success. The standard deviation is just the number of trials times the success rate times the failure rate, and then the square root of that number. So they're very simple formulas. They're not going to require you to type anything into a chart or anything like that to do this. Now the problem is going to come out when, and this is how we write that the distribution is approximately binomial. It uses this capital B, and then it'll list the number of trials and the success rate in that order. So if you see that, then you know it's a binomial distribution. Okay, so we're going to look at some binomial distributions. All right, let's take a look at this here, your textbook here. So a success rate and a failure rate always have to be less than 1 because they're going to add up to 1. So when we say 41% of adult workers, that's going to probably be the success rate. 20 is the n value. Okay. And the probability that most 12 have high school diplomas is a probability that we're going to have to find. Okay, so we're going to have to find that, and we're going to use our calculator to find probabilities. Okay, so if they wanted to know the mean and the standard deviation of this distribution, you could find that simply by using your calculator with these two formulas. But if we're going to find the probability of at most or of equal to 12, then we're going to have to use a calculator that has a distribution built in. Okay, and that's what the 84 has, this binomial distribution built into it, so it can calculate that for you. There is a formula, it's just that we do not use that in this class. It is pretty complex. It's not overly complex, but it is complex. So here are the calculator directions for finding probabilities. So if we're going to find the probability of that it's equal to a number, then you're going to do binomial PDF. Then you're going to put the n value, the p value, and the number you're looking for here. If it's less than the value, then it's going to be binomial CDF. So that's different. PDF is equal, CDF is less than or equal to. You're going to put in NP in the number just like you did up here. Okay, this does a cumulative up to that value. Now if you're going to do greater than, you have to subtract from 1. So if you want to do, that's what it says here, if you want to do greater than 12, then you've got to use 1 minus the binomial CDF of less than or equal to 12. All right, so that would be greater than 12. All right, so let's find out where that is on the calculator. Let's see, the calculator open from the last time. Let's see if I have that still open. No, that's not it. Okay, let's see if I can minimize some of these windows. Here it is, but it says that I need to sign back in, so we're going to just refresh this and see if that will work. Okay, so we're just trying to get the calculator here, so I'm going to need to go back and pick up the we'll generate it again because it doesn't ask us to log again this way. All right, calculator. Okay. Okay, and we drag that off and minimize it down. Okay, so we have the calculator. So basically we're going to need to know where the binomial CDF and PDF are on this calculator, because this is the directions right here to calculate, do that. So basically those are found under distributions here. That's this blue right above vars. Okay, you'd hit second and then distribution, and you can find the binomial in this list. You're just going to scroll down. There it is. It's A and B. Binomial PDF, binomial CDF. Okay, both of those are going to be used to calculate probabilities. Okay, so if we're doing equal, we're going to do binomial PDF, which is this one. So what you do is you just scroll down and you just hit enter, and then you just put in N, P, and X, and then it pastes it into the thing. All right, if it doesn't show that, if it just shows binomial PDF, then you type in NP and F, or NP and X basically in there afterwards. All right, so let's do a problem. Find the probability using your calculator. Okay. All right, so here's a problem. It says about 32% of students participate in a community volunteer program outside the school. If 30 students are selected at random, find the probability at most 14 of them are in the community volunteer program outside of school. Okay, so basically we're going to use at most, so that's going to be less than or equal to 14. When it says at most, that's what it is. Let's go back to here. All right, and then let's say we're going to do at most, so that means it's going to be P of X is less than or equal to 14 is what we're looking for here. At most 14, less than or equal to 14, because that means at most. And then that would be binomial CDF, because we're doing at most, so less than or equal to. And then we put in N, which is 30 here for the number of students, P, which is 32%, and then the X value, which is 14. So if we type this in, this should give us our probability of at most 14. So trials is 30. 0.32 is the probability of success. Oops. And 14 is our X value when a less than or equal to 14. Now some calculators don't ask for this. They just show you binomial PDF like this. You'd have to type this in. All right, we push enter, So our probability here is 3.588%. Or so in this case, our answer is 0.03588. Now if we wanted to do that in a percent, it's 3.588%. Now usually we round to 4 decimal places, so we would probably write that as 0.0359 or 3.59% rounded to 4 decimal places. Okay, so that's how we find the probability using binomial. Oh, I'm sorry, this is incorrect. We're doing less than or equal to, aren't we? So this is this is equal to 14. So if we wanted to know what the probability is at 14, for 14 exactly, so what we have to do is here is change the probability. I chose the wrong one. We want CDF. I typed it in incorrectly, so it should be higher. That's how I knew that it was probably wrong. 0.32 and 14. This one's going to be quite a bit bigger because it's going to add the probability 0, 1, 2, 3, 4 all the way up to 14 on the probability. And the probability 14 is this. So that means this one should be higher. Okay, so this is much higher. So in this case, the answer is not 3%. 3% was for exactly 14. In this case, it's a 96% or 97% almost in this case. So 0.9695 is our decimal here. Okay, or approximately 96.95% of the time you're going to end up with at most 14 out of the 30. Okay, so we just need to make sure you use the right one. Okay, so let's look at some of the homework. That's binomial. Okay, that was back at this, I believe. Yes, homework. Okay, so here's where we ended in the last video. This is question 9. It is a binomial. It says 66% of all Americans are homeowners. If 32 Americans are selected at random, find the probability of whatever here. So these are going to be different probabilities. So we're going to use binomial CDF, binomial PDF. And we may use, in this case, we may use subtraction because it's going to be the other half. Okay? Now, remember that binomial CDF is less than or equal to. So binomial CDF is x is less than or equal to a number. Binomial PDF is x equals a number. That means if we want x is greater than a number, we have to do 1 minus binomial CDF of x is less than or equal to that number. So if we do greater than or equal to, we have to drop down a number because we have to make sure we get that number as well. All right, so in this problem, it says exactly, I'm going to write these out, but you're going to be able to type them into your calculator to figure out the answer, and we'll see if we get the right ones. So this one, for the first one, it says exactly 19. So that's binomial PDF. Now we want to put in n first, so that's 32 in this case. Then P, which is 66%, is the probability. And then exactly 19. So that's going to be the answer to A. Now the answer to B is at most, so that's probability that x is less than or equal to 22 in this case. This was the probability that x equals 19. Now this one's going to be binomial CDF of 32, 0.66, which is the same for both, and then 22 here because we want to be less than or equal to 22. Now C is the probability that x is at least 22, so that's greater than or equal to 22, right? At least 22, so 22 or more. Now that one we're going to have to change it to a less than or equal to, so that one's going to be equal to 1 minus the probability of x being less than 23. No, it's not 23, because we want it to be complementary. That means it has to include all the values. So if we're greater than 22, we're counting it from 22, 23, 24. So we want to be less than or equal to 21 for the complement. So this counts up 0, 1, 2, 3, 4, all the way up to 21, and then this one counts from 22 up, 22, 23, 24, 25, all the way to 32. So we're going to do 1 minus that because it's the complement of the total that we want. This is what they want, but we can't type that in the calculator. So this is going to be 1 minus binomial CDF of 32, 0.66, 21. So 21 is different than the number that's listed in the thing, in the problem, because we have to do its complement, and we can't count 22 both times. They can't be in both halves. All right? So if we're going to go 22 or greater, that means we have to go 21 or less. Since they're discrete, there isn't any values between 21 and 22. All right, we're talking about how many people own homes. You're not going to have 21.5 Americans. All right, so we don't have any answers between 21 and 22, so we don't have to worry about the gap here, I guess is what I'm saying, between 21 and 22. Now D is between 20 and 26, so that means you want to count 20. So that's the probability that the value is between 20 and 26, so it's going to include 20 on this end and include 26 on this end, right? So we're going to do this one, and then we're going to subtract this one from it, because we want to get rid of everything less than, well, we'd want to get rid of everything less than 19. We want to count 20. So basically this is going to be the binomial CDF of 32, 0.66, 26 minus the binomial CDF of 32, 0.66, 19, because we want to take away from 19 and lower. We don't want to take away 20 because 20 is involved in this. It says it can be equal to 20. Just like this one, we took away one less because we don't want to include 22 in our count. We don't want to take away 20 here. We only want to take away up to 19. All right, so if we plug these into the calculator, that should give you your solutions. So you just have to do that in this thing using your distribution. So second distribution, scroll down to A or B, and type them in. So if we were doing the last one here, I would just check the last one. We do binomial CDF, you'd put in 32, 0.66, and 26. And you paste it, and you do minus, do it again, so second distribution, scroll down, binomial CDF, and you clear this, you keep this one that, and you change that to 19, and you paste it. So it does a subtraction between the two. And your answer is 0.7, so 0.7133 rounded up. Okay, now let's just check that. So that's what it should be here, 0.7132. They have the long decimal, but if you round it to 4, that would be the same answer. Okay, so that's just checking that one. Now, that's how we do binomials, and there are just several of those here. Okay, several binomials. All right, now when we get to this problem down here in 13, we're talking about Poisson distributions. Poisson distributions are where we're given an average rate over a fixed time interval, a probability that's given through the average. We use it to approximate the binomial when p is small, like 0.01, and n is large, like 1,000. The mean of the distribution, of the Poisson distribution, is given right here. That is the variance. In this problem, we take the square root of that to get the standard deviation. So this average rate here is going to be mu. They're going to tell you what that is. That's going to be given. All right? Okay. So let's take a look at a question that has to do with the Poisson. All right? Okay, and the Poisson is done the same way as the binomial with the calculator. Okay, so if we look for this, if you go distribution here and you scroll down past binomial, you get to Poisson right here. There's a PDF for equals and there's a CDF for cumulative, and they're exactly the same as the binomial except in what you put in. You only need to put the average and the number. You don't have anything else. You're going to put in mu first and then the number they want second with a comma. Okay, so if I were to put this in, it's going to ask for the average and the x value. They give you this number and they are going to ask you this number and the probability. Okay, so it's the same one. This is less than or equal to if it's CDF, and it's greater than if it's, or it's equal to if it's PDF. Okay, so it's done exactly the same way. All right, now going back to the problems with Poisson. Okay, if you want to do this, it says the mean is 4.4 and it wants to know exactly what it is at 4. You would just type that in to the Poisson CDF or PDF. So you go second distribution, we go down to PDF because it's equal to, and we type in the clear, second quit because we were in the wrong one, second distribution, scroll down, Poisson PDF. The average is 4.4 over time, and you want 4. Okay, so this would be the probability of that. So in this case, 19%, 0.1917. 0.1917 is what they have. Okay, so the calculator will calculate Poisson distributions. Now the variance is the same as the mean. So the mean is 24.2. That's the variance. Standard deviation is the square root of that number. Okay, it's easy to find. Now this question asks you if the Poisson is generally a good, we said that Poisson can estimate the binomial. And looking at this is a very small p-value and n is pretty large, so I'd say yes here. Okay, now the mean of the binomial was n times p, so if you multiply these two together, you should get this value. The actual standard deviation is n times p times q. You'd have to multiply that out to find that value. Now the standard deviation of this Poisson is the square root of the mean. So it's the square root of this number. That's what it's saying.